Welcome back to FPV Reviews. My name is Spike. We have a very special episode for you today. This aircraft, called the Gemini, is our latest creation, and it has some very unique features. As an FPV plane, it's meant to do some things that FPV planes have never done. For instance, carrying two separate video systems, two transmitters with long-range controls. It also has some other unique features like sets of air brakes, split flap type brakes. It incorporates a removable tail. The wings are removable. It stows in a very relatively small box. So even though it has a 3.5 meter wingspan, it is easily transportable. And it's a prototype. It's the only one. We hope someday to have a production model or production version, probably made out of foam with carbon fiber reinforcing. Speaking of carbon fiber, this aircraft has, just in the wings, 16 individual very thin strips of carbon fiber for reinforcing. The balsa structure that you see, most of it is hollow. Most of the airplane was made from 1/16 inch balsa strips, so it's very thin, very light, but also very strong. We load tested the wing by supporting it near the tips and hanging 40 pounds of weight from the center section, just to make sure it would hold an equivalent of about 6 Gs for the aircraft. It has counter-rotating props, 12 by 6, with Part 480 E-flight motors. We found an advantage in efficiency using professional ESCs. These 50 amp Castle Phoenix Edge has been a model that we found we like a lot. This aircraft also has a lot of internal bays and spaces that can carry swappable payloads. At over 11 feet in span, the wing is based on NACA 4412 airfoil. That's a 12% chord to thickness ratio, giving it the ideal characteristics to carry a payload like batteries over a long distance. This is the scale cockpit I've built for the aircraft, and it gives a really nice view from the inside when the GoPro is mounted there. I'm mounted on a servo in the center. It looks very realistic. It's built out of very thin Lexan, and it's just held together with CA. When I'm not using the scale cockpit, I use this fairing that I built especially just to house the FPV camera for utility. It's a little more aerodynamic, weighs a little bit less, and provides really the best view for this FPV camera. It's mounted on a pan and tilt servos. I use it with the head tracker that's made for the Fat Sharks, the one that plugs into the Dominators. I'm really happy with that head tracker. It has a little bit of drift sometimes, but if you stop moving your head every once in a while, it will self-correct within about a second or so. So as long as you learn to do that, it's very nice, and I'm really happy with it. The servo down here for pan is a GWS 125 1T, that's a one-turn 360-degree servo. And with the Fat Shark head tracker, it only actually moves a little more than 180 degrees. That's just the programming of the tracker itself for the IMMERSIONRC gear. But I find that to be perfect. Due to the wide angle of the camera, when it turns sideways like that, I can actually look back and see my wheels, my main landing gear wheels, even though they're behind the airplane a ways. And I've set it up to look almost straight down, and it actually goes over far enough like this so that it does get to a really good look at the ground underneath the aircraft. If that weren't enough, I've added a second FPV camera for that second control system, the DRAGONLINK, and it has a separate video transmitter, so I can have an observer ride along in the aircraft. The setup here is very similar. I'm using that same GWS 360-degree servo and another 720 line or 700 line FPV camera from REDUNDANCY. It's the best one they make. I think it was a little bit expensive, but it's well worth it. And I'm using here a digital servo that I was able to program for full to look straight down, so for full 90-degree turn. And this aircraft, this camera has just an incredible view. It can turn, because it's manually controlled, can turn straight back in both directions, and it can look all around. And of course, being able to look straight down, it is really great. And there's nothing on the ground that you can't see. The only thing getting in your way a little bit is the landing gear, but that's actually good because it provides a field of reference. These are the split flaps I built for this aircraft. They're pretty large, and I put them in primarily to keep the plane at a reasonable speed when in a steep descent. This is the back side of the flaps, the split flaps, or air brakes, whatever you want to call them. And these black strips you see are strips of carbon fiber. That's just to keep that lower surface from bending or breaking during buffeting and high speeds on a dive. Here you can see them being deployed in flight. It may not look like it's finished, but it's covered with transparent film. So you can see and inspect for damage in the structure. We thought this was important during the prototype testing to make sure there's no structural problems with the airframe or to identify them before they become a problem. The nose of the aircraft is capable of carrying 5 5100 milliamp batteries. These are 3 cells. For increased range and endurance, it's capable of carrying another 5 5100 3 cells in this rear cargo bay behind the wing. The autopilot and switch set is also located here, providing all the access you need. This section right here is removable. Not only does it hold the wing down with those 2 screws, but with only 4 electrical connections being unplugged, you're able to remove the wings. The second DRAGONLINK control receiver is housed in this box in the rear part of the fuselage. The IMMERSIONRC Easy UHF diversity receiver is shown here. I made 2 dipole antennas, one horizontal, goes all the way back to here, and one vertical that goes from here all the way down to the bottom of the tail. The vertical stabilizer is also reinforced with strips of carbon fiber to keep it nice and stiff and keep the tail from fluttering. It has no problems like that in flight, and it's very stable. The same was done here for the horizontal stabilizer, and it's removable just with these 2 screws. For the primary flight control surfaces, I'm using these high-tech HS225MG servos. I really like them for FPV because they're not too susceptible to interference or noise in their wires, and they provide good torque and good reliability for this application, probably more than is really necessary. This aircraft is also equipped with 4 hard points on the wings. These are easily removable with just this one screw here. And for instance, this one's being used for the second video transmitter. and each one has a servo lead coming to it, so it can be reconfigured inside the aircraft to do almost anything. These are the motor pods, and I'd like to talk about them for a minute because they're pretty special. I have mounted E-flite 480 Park motors with 12x6 propellers. That's 1020 kV, so very low RPM, very efficient. The motors are specially designed to give maximum cooling right into the motor, ram cooling into the coils of the motor, keep that motor nice and cool. The ducting inside here, even though the design is very simple, is a little more sophisticated. The ram cooling motor that goes in the motor comes out the side right here, both sides. The ESCs are placed further back in here. They have covering over them. There's a baffle in here so that the air is separate from the motor and the ESC, so they both get their own cooling separately, so they stay nice and cool. This is the ram cooling for the ESC. It exits back at the back of the pod on the upper level. They're split. The lower level is the exit for the air that comes beneath the pod right here. So this air that's coming here is not getting hit by the pod or creating any extra resistance. The air is allowed to go right through it and out the other side. This aircraft weighs over 17 pounds when it's fully loaded. A lot of people told me that the two of these Park 480s would never get in the air, but it actually climbs very well, and I've been very pleased with the performance. That's due to its very aerodynamic design. This thing's just about like a glider, and also due to the large amount of lifting surface of the wing. So I've been very pleased with the performance. It could probably have larger motors, but I don't see any need for them at the moment. You might notice too in the general configuration and layout of the aircraft, the accelerated air from the prop wash from the motors goes straight out and clears the tail. So the tail is in nice clean air, keeping the airplane flying nice and smooth and stable. And that prop wash that's going faster isn't running into anything, so it makes the power system much more efficient. And I'm using a Dean's arming switch on this model. Basically what it is a holder that holds the switch, holds one side of the connector. The other side of the connector, which is merely bridged and sealed in something like Plasti-Dip, looks like this, and it just plugs in, and then the model's armed, or at least the power systems are. These are the two transmitters I'm using. They're Futaba 1024s. They're slightly different. The one on the left I'm using with the IMMERSIONRC gear, and it's a heli version. I've had to do some funny programming to get it to work well with the autopilot and the flight controls for the aircraft. It does have an acro mode, but I found that I needed to use these dials instead of switches to operate the autopilot, and I found a way to make the switches operate the autopilot in heli mode, but I had to change some things in the programming. This is an aircraft T8U8F 1024 model. I'm using it with DRAGONLINK. Out of the IMMERSIONRC, I've been able to fly 8.6 kilometers on low power. Haven't tried flying any further than that, although I'm sure it can do it. The DRAGONLINK so far, besides getting a bad transmitter, defective one the first time, has been great. Mike there at DRAGONLINK was very good with his customer support and sent me a new one right away, just from an email. Didn't wait for me to send the other one back. He sent one right out, so I really appreciate that. So far, we were just in flight envelope testing with the aircraft, so we've only flown 4.5 kilometers with the DRAGONLINK on board. but it's been flawless. So I expect its range will be very good, and I'm very happy with it right now. We still have 5 extra channels free on this. Right now I'm just using the flaps on this, along with the pan and tilt for the observer camera on the belly of the aircraft. So we have 5 extra channels. The DRAGONLINK can actually have up to 12 channels, but the Futaba only has 8. And as well with this, we've used up all the channels just flying the aircraft. Ailerons, elevator, rudder, throttle, dual rates, of course, the 3 position for the autopilot, return to home, off, auto circle, and then the stabilization over here, and the 2 extra channels, I believe 5 and 6, for the head tracker port that's plugged in directly to the back of the receiver, or the transmitter, I mean. So that's it for this, but we have 5 extra ones on here for extra items we'll want to add to the aircraft later. So I don't really know exactly what this aircraft will do yet, because we're still expanding the flight envelope, doing flight tests on it, but it's showing a really good promise. I expect it to carry a pretty heavy payload up to about 10,000 feet, keep it there for maybe an hour. Something like a DSLR camera, so it should be able to do that. I wouldn't be surprised if it got up, had the altitude potential for maybe 20,000 feet, carrying a light camera load like a GoPro. Also, its cruise speed is about between 20 and 30 miles per hour, or about 30 to 40 kilometers per hour. That seems like a good, efficient range for it to operate in. It uses about 12 amps of power when cruising at 30 kilometers per 20 miles an hour. And so I've been very happy with its efficiency. The climb rate, not at full throttle, maybe 70% throttle, is about 1 meter a second. So considering it has a flight time of hours and can probably climb under full power for more than 1 hour, I think this aircraft should have a pretty good endurance and altitude potential. I'm really happy with it. I'm looking forward to continuing the flight testing, expanding the flight envelope, and I'd like to close today showing you some footage of the aircraft in flight that we've got from camera positions placed around the aircraft, give you an idea of what it's like. If anybody's interested in building an aircraft like this, I did draw plans for this aircraft when I built it. So I have those. If anybody's seriously interested, I can produce plans for it. And if there's a lot of interest for this aircraft, I might even consider making a more commercialized version out of foam. But I'm very pleased with it, and we hope you enjoyed watching this. If you like what you saw, please hit the subscribe button. Like the video if it was helpful to you or you found it really good to watch, and we'll see you next time. Have a good one.